Summary of steps in booting the system. So the summary of steps in booting the system. We've discussed this before. The post, the power on self-test, when the computer powers up, it runs these routines to make sure that everything's working properly and that it's there. Is the keyboard there? Is it working? Is there a stuck key or anything like that? It kind of has some basic checks that it does. It's called the post, power on self-test. And it invokes the operating system for you, so it loads the OS. The read-only memory basic input-output system, or ROM BIOS, looks for an OS and checks for io.sys and ms-dos.sys. The operating system processes config.sys if present, and command com is loaded. The OS processes autoexec.bat if present, and the command com presents the active drive prompt. The command com presents the active drive prompt. So it tells you which drive you've finished loading on, the little black box up there in the upper right, C:\\. That's the command com presenting the active drive prompt. And the DOS file system. The file is the primary unit of data storage. Files are organized into directories. File and directory names can be up to 8 characters long in MS-DOS, followed by a period and 3-character extension. We know today that these can be up to 255 characters long. Some universal extensions are exe, com, sys, bat, text, doc, and drive. File and directory names are not case sensitive in MS-DOS. The evolution of Microsoft Windows. Early versions presented a graphical user interface for MS-DOS. That's the little black screen that we see, the GUI or the command line, the command prompt we call it today. Windows 3.1.1 was the last 16-bit OS and the most well-known version. It had wide adoption. Microsoft Windows 95 was the first 32-bit operating system. All applications designed for Windows have standard interfaces. So there's a title bar, you know, all this kind of stuff. They had their standard stuff. Multitasking allows users to have more than one application open. So you could have more than one application open at a time. Operating mode. So let's talk about that for a second. Multitasking, we talked about that the CPU is doing more than one thing at a time, right? That's the multitasking we talked about. Operating modes. There was real mode, which it could address only 1 megabyte of random access memory. A lot of the early games had to run in real mode because they had to address the RAM literally. And then standard mode allowed programs to run in protected mode, where they had different setups and configurations. In protected mode, programs could address up to 16 megabytes of RAM. And 386 enhanced mode could address up to 4 gigabytes of RAM. Certain applications included a Windows runtime version. So that's the beginning of the .NET right there, the different runtime. Again, you can see abstraction, abstraction, abstraction even occurring here. And today, we actually abstract software from hardware completely. We have an OS that runs virtually. It doesn't even need the hardware, right? You can put it on any hardware and it'll run. Windows Resource Management. We have apps that talk to the Application Program Interface, or an API. It's a set of routines that do things and translate things. And then they talk to DLL, which are dynamically loaded libraries. So we're talking about Windows here, obviously, Windows Resource Management. And then we have a 386 kernel, kernel 386.exe, which does the discussions or abstraction to and from the device drivers, which actually translate into hardware commands. So the device drivers actually map memory and things like that. They actually deliver commands to the hardware. And then in the more modern versions, this is known as a HAL, a hardware abstraction layer. Again, abstraction, 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 right? Everything is abstracted from the hardware. Why do they do that? Well, the reason they do that is so that when the hardware changes, I don't have to change all of my software. It's millions of dollars to do that for some big applications, right? And you don't want to have to go buy a new version every time you change some hardware. So that's why we have all this abstraction, abstraction, abstraction. Memory paging and virtual machines. So virtual memory is an area on the hard drive called a swap file that the system uses to store program code temporarily. So we take pages out of memory and lay them onto the disk so that we can reuse that memory and free up memory, right? Things that we haven't used for a while, the computer will swap out to the disk. Virtual machines, or VMs as they're called, allow multiple programs to operate. So VMs allow multiple OSs to operate in today's world, right? And DOS programs run individually in separate VMs. So this is a concept. The VM here, a virtual machine, is a concept for DOS programs. So we had a little window that we would encapsulate a game into so that you can load it, and it would have all the access that it needed to. It could literally address the RAM inside of its VM, and then the OS would abstract that and say, okay, he's trying to do this, he's trying to do that, let's let this game run. VMs came around because games weren't running on the newer OSs, and people were addicted to like crack cocaine with some of these games. So it was very important that they actually contain these things and allow them to run. The complaints were unbelievable. I've read some of these on the internet years and years and years ago. It was unbelievable. People would go crazy. So you got to be careful about that when you build something, you know. So today the VM concept is different than what they're talking about here, but it's kind of the same. It's a more formal process today. There's actually ways to do it like VirtualBox, VMware. So this was the dawn of VMs.